I'm working on the printer mechanism for the ASR33 that I'm restoring, and in the previous video we got as far as installing the motor, getting it to run up and start going through a print cycle, but despite me doing that, and I've been doing some more testing on it since the end of the last video, it never tried to print a character, so it never rotated the print head into the correct position, and it never actioned the hammer, so it was never actually trying to print a character. I suspected that the encoder bars were stuck, and it's quite hard to show this on camera, but that turns out to be what the problem is. So the way that they're controlled is that during each full print cycle, each of the encoder bars is either set or not set, depending on whether that particular bit position in the data value is a 1 or a 0. And the setting of the encoder bars is done through a large solenoid. I'll just try and lower this light a little bit, but under here you can see a cover over it is a, let's try and get the light even lower, there's a cover here, there's a solenoid behind here, and as the printer goes through a full cycle, the solenoid is either energized or not energized for each bit as each bit is scanned. And what it does is, if it at the correct time in the cycle, if a particular bit is supposed to be set, it raises one of these arms, the appropriate arm for that particular bit. And when the arm is raised, it in theory should release the encoder bar that's associated with that control arm. So if the arm comes up, the encoder bar should move across, and it's moved across under the control of one of these springs. Fairly light springs, so there's not a lot of force in moving them. I'm going to zoom the camera into this area so you can have a closer look at what's going on. Okay, so the copper coloured bars are the control bars, and these long bars running left to right are the encoder bars. And what should happen is, during a particular part of the cycle, if these control bars are raised by the solenoid, then the applicable encoder bar should move across and up. So move across to the left and upwards. So I've got the printer manually turned to the point where the encoder bars should be released. So when I raise the control bars, then all the encoder bars should move across. So if I now manually raise the control bars, so all I'm doing is putting a screwdriver underneath their tips. You can't see it, but I'm now going to raise them. Okay, so I've raised them all, and you'll see that 3 of them are moving. So the first one, the one nearest to us, is moving. The next one back is moving. If we skip 2, there's another one moving. It's quite slow to move, so it's not getting the same solid clunk that the first ones are. But the rest aren't moving, they're locked up solid, and however hard I push them, I can't get them to move. So I've been putting some lubricants on these, and they basically bind up here. There's a post that they sit on here that controls their action, so it's kind of a ramped slot in each of the bars, and as it moves from left to right, it raises it as well as going to the left. So what I need to do is free up the remaining bars. I've done these 3. I need to free up the remaining ones so they should all move across when I raise all the control bars. So I'm just going through, working these, putting some lubricant on this part where they're bound up, and hopefully they will free up. So I'll work on these some more, try and get them freed up, and then demonstrate them all moving. Okay, I've been working on freeing up the encoder bars. Some of them were really stuck. I had to spend quite some time freeing them up, and I got to the point where I was considering taking the encoder bar block out completely, but finally I got them freed up. If I now raise the control bars, you see that all of the encoder bars will now move back and forth. If I manually move them side to side, you can see they're all moving as they should. So what I can do now is try and run it back through a print cycle and manually move a couple of the control bars and see if that translates into the printer trying to actually print a character. So I'll just reposition the camera so you can see more of the printer, and we'll give it a go and see what happens. Okay, I'm making progress. I've got all the code bars released. Some were well and truly stuck. I've also cleaned up the cross links and the riser links that go up to the print head. And what I'm going to do now is just try and run it and see if it will go through the 3 modes of operation, or the 3 basic modes of operation. The first one is to release the H-bar link, which is this link down here. Normally it's held by the keyboard. It's released when you press a key, and that puts the printer into print mode. With this held down and the start bit relay in the basically the home position and the little plastic toggle raised, then nothing should happen other than it go through a kind of a dummy print cycle, but nothing else should happen. The distributor should not rotate. Okay, it's very loud because there's no rubber mounts on this, and it's just resonating through the workbench. But as you can see, it didn't rotate. What I'll do this time is I'll start the motor, but I'll release the H-link lever, and as long as I have that released, you should see the distributor rotating. And when I press it back down, this should stop when it reaches the end of the current cycle it's on. So that seems to be working. If I now hold the lever down, but I manually trigger the this is effectively the bit NOR, the start bit relay. And when you talk about ASR33 or serial communications, you have a start bit, one or more start bits. And originally that was to trigger the printer to put it into print mode, and then the rest of the data that came in through the serial port was used for the actual printing. So I'll just very briefly trigger this, and we should see it do 1 complete cycle each time I trigger this, and when it gets to the end of the cycle it should stop rotating the distributor. Okay, that seems to be working as well. And so the final mode is the answer back, the who are you mode. So this unit on the back, this drum that we looked at in a previous video, hasn't been encoded with anything, and effectively the plastic lever on the front, the one that's broken, that triggers the who are you. It's only got one function, and it's hit by a particular, it's triggered by a particular key on the keyboard, and it puts the printer into an auto answer mode. And it will go through and it will in sequence send all the encoded bits that are on this answer back drum on the back. So when we push this plastic lever down, assuming we have the H lever down and it's not being triggered by the start bit solenoid, then once we press the plastic lever down, it should cycle through all the characters that have been programmed into this selector drum. So in other words, it should start the distributor rotating for a while, and then once it's gone through the entire sequence it should stop. So we'll try that. So that's working as well. Now it's not printing anything here because we don't have the actual solenoid hooked up. So there's a big solenoid back here that is responsible for setting the code bars in response to the data that's being sent to the machine. So for the rest of this video, I've been asked how this works. So for the rest of this video, what I'm going to do is just very briefly explain the operation of this unit. I'll skip over quite a few of the finer points. A lot of the complication is because there are various command functions. So you've got shift, you've got certain control functions that are non-printable characters, but that the printer has to respond to. An example of that would be the bell. There's a bell character. It's not printed on the paper, but it causes the bell to ring on the printer. But obviously the printer needs to be able to decode that and respond accordingly. And that's what this unit here is for. It's basically the function unit that responds to particular codes. So it tends to make the overall operation of the machine more complex. But what I'm going to do now is I'll spin this round, and then I will fairly briefly explain how this unit takes incoming data and prints it on the paper. If you're familiar with these machines, you might want to skip the rest of this video. I'm just going to give a brief explanation as to how this machine functions. It can be useful if you've got one of these and you're not familiar with the inner workings. I'm going to gloss over a lot of the finer details and give just a basic explanation as to how it functions. The first thing to bear in mind is that the printer in these machines, whether you're printing from the internal keyboard or through a serial interface, still prints in a serial manner. So if we look at the serial data that we want to represent as a character, this is just an example, of course. We start with a start bit. This is just an example of the serial data. There are different formats and different ways this can be implemented. But if we assume there's a single start bit, then that start bit is used when the machine's connected to a remote machine to trigger the small relay, little solenoid on the back that I was pressing manually. That's then followed by the actual serial data. So in this instance, if we assume we've got positive going signals or a 1, then we have a 0, 0, 1, 0, 0, 1, 1, 0. So it's an 8-bit machine. And that value would of course represent a particular character. So how does this machine go about translating this into a particular character? The characters are of course on the printer drum. So that's this up here, this is the print head, and it's a cylinder, and if you imagine this laid out flat, then it's a grid of characters. So you would have, in this case, it's a 16 by 4 row array. So I won't draw all of the grids, but effectively what we have is a center resting point. So of course this is normally wrapped around that cylinder, and if we rotate the cylinder in one direction, we can select characters from one side of the cylinder, and if we rotate it the other way, we can select a different set of characters. If we then raise or lower the cylinder, we can select one of the rows. So to select a particular character, say we want to select this one, then we have to rotate the cylinder 2 places in that direction and then raise the cylinder 3 rows. And that's how the printer works. The question is, of course, how does it go from the incoming serial data to rotate the cylinder into a particular position, raise or lower the cylinder to the correct level, and then sequence all the particular actions. And it's quite clever, but it's also fairly simple in the way that it operates. We'll start off looking at the machine in serial mode, remote mode, because it really does the same thing whether it's printing from its own keyboard or from a serial port. And when I say a serial port, it's normally a current loop on these older machines, but it can be RS232 if there's a conversion circuit somewhere. So effectively the incoming data starts off with this start pulse, and the start pulse is used to control this solenoid. That solenoid starts the print cycle, and the print cycle, printing a character, is achieved in one full revolution of the machine. So this distributor is not used when the data is coming from a remote interface. What we do have in both modes is there's a small circuit board that isn't attached to this. We'll have a look at that in a later video. And all it does, it takes the small low-level signals coming in either from the keyboard or from the remote machine, and it uses those signals to control a large solenoid. You can't really see the solenoid very clearly. It's in here, that's what this is, and all that solenoid does is it moves this actuator plate. There's a small plate here, and that's used to control the printing. And the way it goes about this is the machine starts a print cycle, it starts rotating the machine. There are some fairly complex levers and cams and whatever, and one of the reasons this overall machine is so complex is because it runs very quickly. So just before we go into how the printing occurs, we'll just cover very quickly the speed issue with this machine. So as with any complex machine, the faster you go, the more problems you get trying to make it work correctly. So firstly, the motor takes maybe half a second to spin up to speed when you apply power, and although that sounds fairly quickly, it's way too slow for this machine to respond to serial data. If it was stationary and data came in, we're talking here about milliseconds for the machine to respond. So the motor runs all the time, and what happens when you trigger the start relay, one of the things that occurs is there's a series of levers and cams in here, and they are used to trigger the main clutch. So normally this thing spins around, and this clutch here is freewheeling, and inside this gear there is a clutch mechanism, and on the outside of this there's a little tab that sticks out, and this is normally whizzing around at high speed. And if you want to engage the clutch, what you do is you move the tab, and that enables the clutch to engage, and it starts the machine spinning. The little tab moves back into position, and so at the end of the full revolution it stops or disengages the clutch and stops the machine running. So it means the motor can spin all the time, and then it can very quickly engage the drive when it needs to. In addition, this other complex looking mechanism at the end here is used to determine where in each bit we effectively sample the data. So it's important that the incoming data is synchronized with the machine, and it's also important, that's important why the machine data rate or the bit rate is very consistent. It has to match the machine. Now usually it's not a big problem if you got another one of these machines, because motors like this run at a speed that's specific to the mains frequency, so they should be running at identical frequencies. You tend to get more of an issue when you're looking at computer derived data that might have errors in the bit rate. But we need to be able to tell what the data value is supposed to be for all of the bits. So at each time interval through the print cycle, it samples the incoming data, and then it uses that to determine whether the solenoid needs to be energized or not. So for example, we could say that for all the ones we need to energize the solenoid, and that's done through the small interface, small driver board. But it's not quite as simple as that, because if we were to sample at this point, because of the delays in the mechanical machine, you'd find that by the time you got round to actually actioning that, then you're too late. You've missed the point at which the machine needs to have processed that data. So this is kind of a look ahead timing mechanism. It allows the machine to have a chance to respond to the data, and then the mechanics can keep up with the incoming data bit stream. Doesn't mean it needs to be set correctly. If it's not set correctly, you end up with it printing the wrong data because it's sampling at the wrong time. But it tends to make the overall machine look more complex, but it's just there to keep the timing correct. Okay, so we now need to translate the incoming ones and zeros into a way to manipulate the print head drum. So that's done through this series of cams and fingers. So you've got these cams, and they're all offset cams. The way this system works is that each of these levers, as the machine does one full revolution, is effectively enabled, and they're enabled in sequence, one at a time. And as each one is enabled, it is being used to sample a particular bit. So there's one cam for this bit, one cam for this. So there's a separate cam, and there's one of these cams for each of the bits that we need to sample. So there's just a small detent on these, and it allows these levers at the bottom here to raise at the right time in the print cycle. What therefore, and this is, you're not going to be able to see this, I'm just going to try and explain it, but it's quite difficult to see. So what we have now is those little levers that are being controlled by the cam are sitting with little tabs underneath the plate that is controlled by the solenoid, and they want to try and raise a little spring on each one, and as the detent in each cam comes into place for each of the levers, they want to try and come up. Now if the solenoid is in one state, I'll try and bring a light down so you can see possibly. Okay, so what you've got is each of those arms has got a little tab on the end, and you can see this tab here, and this is the end of the armature. This little plate here looking edge on is the armature for the solenoid. If it's in its non-energized position, then the tab cannot come up. It's prevented from coming up because the end of the arm hits the plate. But if the solenoid is energized at that particular instant, then the little tab misses the plate, and that particular lever is allowed to come up. What that does is it enables the associated control lever, which sits to the right here, to be raised if it's allowed to. So in other words, if the little tab here is allowed to come up, then it causes the associated control lever to be actioned, and they just raise like this. And when they raise upwards, you'll see these little fingers on the bottom. Those fingers engage with the code bars. So if for a particular code bar this arm comes up, then the code bar under spring tension is allowed to come towards us. As it comes towards us, it runs up a small like a inclined cam, and that causes the code bar to be raised inside the machine. So what we've done here is, as we've gone through the full cycle, or partway through the full cycle, we've sampled all the incoming data, and then using the cams inside this unit, the solenoid, which is triggered at the right instance if we want to have a 1 or a 0, and that's used to set all these in particular position depending on the data value that's needed, and that in turn sets all the code bars. So I'll spin the machine round, we'll have a look at the code bars. Okay, so these are the code bars. There's a series of springs at this end, and if the, let's move the carriage across. So these are the control levers at this end, and depending on how they're manipulated through the first part of the print cycle by the solenoid, you'll end up with a certain combination of these code bars. Some will be raised, some will be still in their lowered position. So these are used then to control the print head. So let's return this to its center position so you can see it a bit more clearly. So I'll spin this round, and again you're probably not going to be able to see this very well, but under here you've got these code bars, and underneath at the tip of where the screwdriver is you can see there's a little shoe that rides along each code bar, and there's one for each of the main code bars, and they go up into the actual print head itself, or the print head mechanism. And the way they're used is, if we look down inside the print head, and sorry you can't really see much of this, but it's quite difficult to get the camera in there. There are two racks. There's a gear in the center that's attached to the print head, or the shaft that the printhead rides on, and there is a rack on the right of that gear, and there's a rack on the left. The fifth code bar back is used to determine the direction that the head will turn, so depending on what the bit value was for that particular bar. So it will rotate either anti-clockwise by selecting the right hand rack, or clockwise by selecting the left hand rack, and then there's another lever that comes up to move those racks back or forward, and that causes the head to rotate into the desired position. Not quite as simple as that, of course, because we have to decide not only which direction to rotate but how far to go. So there are two more code bars that are used, and on the matching control plates, that's the ones that sit on top of the little shoes we looked at, there are two plates that have coded slots in them, and depending on whether a particular code is on those two bars, it puts the slots into a certain pattern, and that dictates how far back the rack that's been selected can travel before it stops, and that of course determines how far the head will rotate. We then have to determine how high it's going to be raised, which roll we're going to print from, and again there are two of the code bars that are used to control that. Again, a little series of levers controlled by the shoes that ride along the code bars, and depending on the combination of those two code bars, whether they're up or down, it will determine which of those levers is set or unset, and that in turn determines how far the printhead is raised. We then have another code bar, which is the one that's the second one from the back, and that's used as a print inhibit. So that's used when we don't want to allow the machine to print. It might be a control character, for example. And then underneath here, I'll just lower the camera so you can have a look underneath the printhead. So to print the character on the paper, there's normally a ribbon that goes around here. I've taken it out at the moment, but this impact bar, it's got a little rubber pad on it, and as the print cycle progresses, there's a big helical spring that runs along the shaft that this pivots on, and that is used to build up some spring tension, and then at the appropriate time in the cycle this lever moves out of the way and it causes this impact pad to strike the printhead, and that in turn pushes it against the paper, and then whichever character has been selected will be transferred onto the paper through the inked ribbon. There's another of these levers down here. Notice this didn't go all the way across. There's another lever. If I pull that one out of the way, notice it did then go all the way across, and that second lever is the print inhibit, and that's the one that's controlled by this second bar from the back. So you can see that as well as having the basic mechanism for printing, there's quite a lot of extra complication to allow it to do various other things, such as inhibiting the printing. There's also a shift code bar. So all those work together to enable the machine to select the particular character that it wants to print. So that's how it works in serial mode. I'll just move the camera and we'll discuss how it prints from its own internal keyboard. So when the machine prints from its internal keyboard, then you press a key. The keyboard itself encodes the data on a series of switches, and also it toggles or moves this lever here. This is the one that the H-link is attached to. This is the only mechanical connection between the keyboard and the printer. There is this plastic tab as well, which I showed, that's for the answer back, but that's not really used in normal printing. It's just that this is used to trigger the print cycle, but it does not transfer any actual data from the keyboard. The data is transferred through a series of switches, and they are fed through to the connections along the bottom of this. You've got this distributor, and the way this works is on the keyboard you have a series of switches, which is, I've shown 4 of them here. There are of course more, but they all work in the same way. So depending on which key you press on the keyboard, the switches on the keyboard are latched in either the closed or the open position. As the machine goes through its print cycle, the contact is transferred from the center, the common of the distributor, to each of the segments on the distributor in turn. So what it's doing is checking the value of each of the switches. Now if any switches are closed, you will of course get current flowing. If any switches are open, you'll get nothing. That's fed through as serial data, because of course what you end up with there is data that looks like that, and the data will be dependent on the key that was pressed. That's fed through to exactly the same board that is used to control incoming data when it's connected to a remote machine. So the output of this distributor is effectively exactly the same as the data that comes from a remote machine. It takes the parallel data from the keyboard and it translates it into serial data that the machine can handle in exactly the same way as it handles data from a remote machine. So it's as simple as that. All this does, it takes the data from the keyboard and it turns that into a serial bit stream that's used to control the printer. The last element on here is this answer back, and all that really does is it puts the machine into continuous run, but the data is then being sampled from the answer back unit. The answer back unit is this drum here, and you encode the data by snapping these tabs off. So that's pretty much it. There are of course many other things in here, and all this complication that we see is really the function generator, so it enables us to have the printer respond to different functions. But the general operation of this is fairly straightforward. Once you know what each part of it's supposed to do, you can slowly rotate this and see what it's doing, see which bits are moving, which bits aren't. Normally things are just stuck or out of adjustment. Don't adjust anything or don't try and get it spot on when it's being driven slowly. The settings will be very different when it runs at speed. So you need to get it fairly close so nothing's damaged while you're just driving it around. So go through full cycles and make sure that it will rotate freely and smoothly without doing any damage to the machine. If you feel any high resistance, then don't try and power it up. You'll almost certainly damage something. Other parts of the mechanism are of course there to rotate the platen to drive the paper forward when you have a line feed, or to return the carriage to its home position when you issue a carriage return command. So again, the carriage return is a non-printing character, but it's interpreted by the machine and the function unit at the back to return the carriage to its home position. So hopefully that made some sense. It's very difficult to explain in a lot of detail how this works. They are fascinating machines, and it's one of the bridges between old mechanical machines and modern computers. But there is an amazing similarity or parallel between the way this works and the way that a modern RS-232 machine works. Okay, in the next video what I'm going to do is put this back into the chassis. I've taken this really as far as I can without connecting it to something that can supply some data. I do need to still repair this little plastic tab down here, so I'll do that. Fit this to the chassis, and then the next step is to look at the electronic control unit. That's the big unit that sits to the right, and that's what we'll look at in the next video.